Is this working now? Okay, so it's probably weaker because I'm not using actually this microphone. I don't know why it's not working, but hopefully you can understand. Do you guys understand what I'm saying, or do I need to speak louder?
Yeah, no, I can hear you.
Okay, very good. Okay, so today we have quite a few things to talk about. And I know we have a lot of assignments, and I'm glad that some of you are here. This meeting is recorded actually, and it's going to be posted back on Canvas so that the people who couldn't make it at least will have a chance to go through it and understand basically what they need to do. And so let me go to the topics that at least I thought we're going to cover. Again, this is an open session, meaning that you guys can also come up with items. So I encourage you next time around to also think of things that you, for example, have issues with so that we can fix them and we'll talk about them, okay? So let me share my screen, at least the things that I had in mind. And I know I sent the items to you guys on Canvas. Okay, via communications. Where is it here? So these are the things that, do you guys see the screen or is it too small? Okay, good. So let me make it bigger just in case, okay? Okay, so the two projects, we have two projects now going on, namely the retrograde motion of project and also the lunar observation. The lunar observation, you still have time to do it, but it's actually spanned over the entire period. So it's not like I'm going to delay it to the last day or the last week and then I start working on it. No, you have observations that you actually have to do, and they are timed. You have the times on Canvas when you need to go and do your observations. So yes, the report you don't need probably to start on it right away, but your data, namely the position of the moon, how it looks like. When I say the position, just basically, is it south, southeast, southwest? Is it north, depending on where you find it? And is it like, for example, right above your head, like we call that the zenith, or is it just, let's say, for example, midway? So you don't have to give me an angle. You're not going to be giving me precise measurements in here for the position. Just basically a rough idea into where it is in the sky relative to where you are in that night. So its shape, how it looks like. Is it a full moon? Is it quarter moon? Is it whatever you think is it a crescent? Is it whatever you think the shape of it is, and then which way? So you have to tell me which way it is, and then also you draw it. You do a draft basically on how it looks like on your on a piece of paper, and then at the end you're going to transcribe those data to the report. So that's the first step. So the first step as far as the lunar observation is to actually go and do a lunar observation. You're actually treated with an outstanding thing that you probably are going to be unique to you guys, and that is we have a lunar eclipse this weekend. So I mean, that's part of your requirement to the report anyway, but I actually strongly urge you that you go outside and you do the actual observations and enjoy yourself in a sense also. It's still the 4th of July, which is a holiday, but also you're treated for an extra thing in here. So the celebrations do not end with the sunset. You still have a lot of things going on at that night. So that's one thing. The other thing also, I have assigned a homework for this week on GeoGebra, and I gave you the link for it too. So I want to have you feel for that and how that works so that you're comfortable with how to go there and change the data. As you change the data, you will answer the questions. Basically, there are question 1, 2, 3. I think there are 11 or 12 questions in the assignment. So you need to do those steps and follow them and make sure you can finish them. And then the quizzes. We have a quiz from last week that we didn't do last week, so it was due early this week, but we have also quizzes that are for this week. One of them actually is kicked in just about 6 minutes ago. That's for chapter 3, I think. You still have more chapter 4. That is also going to be a quiz. Depending on how it goes with my recording for chapter 5, I may have another quiz if I finish the recording for chapter 5 by the end of today, which means I have to post everything for chapter 5 by the end of the day, worst case scenario by noon tomorrow. If that's the case, then you will have another quiz for that chapter 2. But if I am delayed in terms of my recordings and things like that, because I have to record and then basically edit it and then upload it, so it takes a little bit of time. So if that's delayed, then we're going to delay that to early next week also, just like what happened with the first week. So this is basically in a nutshell the items that we're going to be talking about. The retrograde motion and Sitlali, I'm not sure if I'm saying it right or not, okay? Ask me a question and run to a difficulty, and I really want everybody to understand the idea behind it. So let me go back and see if I can find, and let me see if I can log in as a student first, okay? I don't want to have the instructor view, because like last time we discovered a few issues when we were in the student view, and hopefully you guys have seen that they were corrected. So I don't want to have the same issue as before, so that we are in the student view. So let me stop sharing that screen with you guys, and let me share with you my screen now. So right now I am on Canvas, okay, as a student, okay? And so I'm gonna go to the modules. That's my starting point. I want to do all of my assignments. And of course, I have the retrograde motion in here that is telling me that I need to do that, okay? It's marked me that I have done it. And that's actually a discussion. I'm sorry, let me go back, step back. Okay, so these are the steps. These are the basically what needs to be done. One of the questions that was asked to me, I don't know who asked it right now, but where am I going to find the answers? The answers to these questions, some of them, they should be in the instructions, and some of them are actually in the textbook. So I strongly urge you to go back and read the chapters in here. I know one of the things I didn't really clearly state last time, and that is for this chapter, which I abandoned now with the second week. With the first week, for example, the overview or the history of astronomy, if you go to it, you would think that that's all there is to it, that this is the entire thing. But it's actually tabbed. So I'm going to go back into here and see the second tab in here and see, and this is actually the point that it talks about this is the heliocentric model, and that explains how the retrograde motion is. So basically that is part of the assignment. That is taking it straight from the book. So to answer this question is come back in here to this point in here and try to understand what's going on. Here is how the radius of the Earth was measured in the by Eratosthenes, and that's in the time of the Greeks, about 400 BC. So this is basically 200 BC. So this is basically on how the some of the measurements were done. And here, actually, the retrograde motion in here, and it talks about Galileo and so on and so forth. Again, this is just a summary. This is just notes from the book. So I want you to make sure that you read these things and understand them. So the questions can be answered straight from the book. You are free also to Google and go to any kind of resource that you will find in there, but please do cite that resource if it's not the textbook or something else, okay? Make sure you mention that this is where I found this information, and this is basically the answer to that question. So let me continue back with the assignments here to understand what the issue of Sitlali that was mentioned. And I think that's going to benefit everybody. So in here, it says, please use this link to submit your assignment. And it's giving me the breakdown on how this is done. And it's giving me a fillable file in here, okay? And it's actually giving me the retrograde motion also, which is a PDF file. So if I click on that, it takes me back to the, so I removed the PDF file, I'm sorry. So it takes me back to the instructions, which is detailed, actually. It gives me everything that's exactly the same thing as the content in the PDF file. But now, I have the PDF fillable file. If I just click on it and start working with it, Actually, my computer in here, it defaults to opening it with Adobe Reader. But if I click on it and try to open it, let's see if it does it. It's still on my computer. It's prompting me to save it on the computer, which is exactly my point in here. What I want you to do is right-click on the file. I don't know if you see the pop-up that popped up when you right-click with the mouse. Don't left-click. This is a mouse. Okay. You have the normal click, which is this one, and then you have the right-click, which is the other one next to your to the other side, to the right-hand side. So when you right-click on it, there is a pop-up window that pops up. And it asks you, among other things, on Firefox, it tells you to save link as. Depending on the browser, you might have a different names for this option, but you save link as. And in this case, you choose a place where you're going to save it. And did I put it in here? Let me try to find a place for it in here. I'm not sure if you're looking at this or not. And I saved it on my computer. Now it's on my computer. I need to go and find that file on my computer, and I'm going to show you the screen quickly of how that looks like. So I'm going to stop sharing that screen, and I'm going to share with you that screen. This is where it is on my computer now. I saved it to a place where I know where it is. Now, if I open it, I have to right-click and make sure. If you double-click on it, it may be showing something else. Maybe opening it with probably Chrome or Firefox or maybe Edge or Safari or any other browser. That is not what you want to do. What you want to do is make sure you open it. In my case, I have Adobe Acrobat, but you could have Adobe Reader, okay? Adobe Reader would work the same, absolutely the same thing. So I'm going to open it, and now I'm going to stop sharing this file in here, this screen, because now I need to go back into the new screen that popped up. And now I have the fillable file opened by the proper source. And it's giving me all of these highlighted things, among other things, this red boxes. The red boxes are required boxes. So if I work everything and save the file and don't include something in the objective in here, including space, by the way, is accepted. So if I forget to, if I put a space in here just as a fillable thing so that I come back to it like a to-do thing, it's going to work. But usually, if I want to come back to this thing in here, I write actually a to-do. Okay, so that later on I remember to do this thing. But the point being in here is that once I am done with this, making sure that I have done everything, answering all of the questions on it, and I answered all of the questions, filled out all of the things in here that I have done the calculations for, based on the formula that is in the instructions. Then I have to write something in the conclusion in here, whatever that is, and the instruction tells you what that conclusion should look like, basically about retrograde motion in this case. Now I have filled out the form. Then in this case, I go to File and Save. If I don't save it, it's not going to work. When you upload it, it's going to be a blank file. So if I save it, before actually uploading it, I have to open it one more time to make sure that what I have done is stuck basically to the file. Now, another question that came up in the questions that were asked by somebody else, I believe, is how am I going to draw the lines? I can't find the thing for it to draw the lines. If you have access to the comments, you click on the comments from your Adobe Reader, and you go to the drawing marks. There, you pick up either the pencil or the line, and then start drawing the lines. For example, in here, I'm supposed to connect the Earth to number 1. Try to not come straight from the Earth, comes straight, slightly outside of the Earth, and then draw the line. Again, this is if you want to do it this way. Okay, you don't have to, but this is an option. So, and then I'm gonna put a note in here. I'm gonna add the text in here saying that this is 1. Okay, this is clearly for 1. This is position 1. Then I'm gonna take another note, another pen in here, and go to 2. Okay, and this again is number 2. Okay, I hope you get the point in here. Then it's going to be hard. Okay, so I'm not going to lie to you after that. Okay, because once the lines are close, you have to be very, very careful in here. Don't worry too much about where they intersect and make sure that everything lines correctly. Because the point for it in here is just to see that this object is moving up in the sky in one direction. Below 7 is going to be below, and 8 is going to be below, and 9 is going to be somewhere in here, more than 3 but less than 4, and then 10 is going to be clear of everybody. So it's clear that Mars is going to be going forward in motion, then back, then it's going to be moving forward again. So that's the geocentric model. Okay, this is Ptolemy and the old people basically and how they used to do it. So again, as long as I have access to this tool, if I can do it in here, print this, draw it with hand, with a ruler and a pencil, and then scan that thing or take a picture of it with your phone and include it. As long as you do the practice in here, you're going to lose a lot of points if you don't do this. So it's very critical that you do this step in here. I think it's worth 5 points out of the entire project, and the other one also is worth 5 points. So if you forget to do this, you lost at least, now you've lost a lot of points for unnecessarily in here. Same thing in here. If I can have access to the comments tool, I'm going to connect 1 to 1. So this is actually easier. Okay. And come in here, and right next to it, that this is position 1 of Mars in the celestial sphere, as I'm looking at it in the sky, basically. And connect 2 to 2. Here is 2, and make sure 2 is connected to 2. So again, this is 2. Again, I'm seeing it moving in one direction in the sky. 3 and 3. Here is 3. Oops. No, I'm sorry. I need to make sure that I'm doing the line, not the writing. Again, 3. So again, you can do this with your Adobe if you can. If you can't, so 4 is going to be here somewhere. 5. Oops. I make sure I go back into the. I did not label this as 4. Don't forget to label your positions, okay? So that you know which line is which. I mean, you saw it the first time, the second time, the third time, and so on and so forth. Okay, so you're going to be 5 now. Oops, Control Z. The nice thing about this one is when you're doing it in a computer, if you make a mistake, you cannot. You see 5? 5 comes back. 5 is actually below 4. So it's clearly Mars now apparently is moving backward. Okay. 6 is going to be even more backward. 6 is actually below 3. So it moved way backward in here. We're almost back to position 2. And so on and so forth. So this is the heliocentric model. Again, if you can draw it by hand, I mean, if you can't draw it on the computer, you can draw it by hand. As long as you do the actual activity and you have an understanding of how the position of Mars looks like in the sky and answering these questions, okay, at the end, based on your actual work, not on some resource somewhere else, I'm glad. I'm happy with that. Otherwise, you're going to lose a lot of points unnecessarily, which I really, really hope that you don't do that, okay? That you really take this thing and do it by hand, and if you can do it on the computer for some reason or the other, okay? These are so-called comments. They should be accessible in Adobe Reader. If for some reason you cannot access them, then you can basically do them by hand. Like I said, just print the thing and draw it by hand and take a picture of it if you can scan it, and then send the thing, okay? And say, okay, I attach the 2 things plus to it, because there is no restriction of the number of files you can upload on the project itself. Is this clear? Okay, good. So again, this is going to be recorded and it's going to be uploaded. So if you guys have any questions, or those who are not here, hopefully they will access it and see the steps, and they will do this project, and they will record it. At the end of the day, don't forget to save the file, because if you don't save it, let me go back into it and see, make sure that you guys understand that last part, because it's critical that we have to do that. Obviously, I have to fill something in here. about the conclusion. Otherwise, this thing won't save for me. So I'm going to say, I don't know. I'm just going to write CON in here because I really don't want to. If I do save it without anything, it's not going to save. Or at least, what is this thing in here? Why it's not moving fast enough? Okay, we're almost there. And in here it's going to be intro. Okay, intro, not intro. Okay, so now I'm going to come in here and save the file. Okay, I'm going to close it. Oh, okay, that's fine because I closed it. So I'm going to go back and open it again and then share it to see if the information I have just done have been saved or not. So let me go back and share the screen now. I closed it, remember, and I just opened it again. Now, at least the required fields are there. This file was saved with all of my remarks, with all of my comments and everything, and I can upload it now. It's ready to go. As long as I answer the other questions, of course. Don't forget that you have like a few other questions that you need to complete and other tasks to do and everything else. So I'm going to stop sharing this screen. And hopefully this covers at least the idea with the PDF file and how to make sure that you work with it and how you download it and you do your things and everything else. Now, for the lunar observations, the biggest task right now is actually to do those observations. Find the moon. If you can see it tonight, for example, if it's required tonight, then you go the day after. It's cloudy, for example, or something. But if it's not cloudy and you can see it, just report that it's not there. I couldn't find it. I went at 9 p.m., I went at 10 p.m., then I had to sleep, then I woke up at 5 a.m. or 6 a.m., and it's not there. I couldn't find it. It's not anywhere in there. That's it. You're done. You did your task. You don't have to worry about the rest of it. Now, if it's cloudy or for some reason that you cannot go out or something, you have a night shift working in the hospital and they couldn't, then it's fine. You can do it the next night. Okay, so you have about 3 nights. At the end, don't lose sleep over it. Just basically state the fact that you couldn't see it because it was cloudy 3 nights in a row, and put that as part of your report, and that's acceptable 100%. Please do not Google the position of the moon so that you're going to go and include somebody else's observations or how it looks like from the vantage point of something or somebody else. No, that's not going to be acceptable. What you need is the time you went, of course, your location, and how the moon looks like, and a hand drawing. Okay, and its position, of course, in the sky. So all of these things, try to document it, and then at the end of the course, which is the last week of the course, you're going to be submitting the report, and it's similar. It is not different than this report. It's a PDF fillable file. Again, it's for some reason, and drawings are going to be a challenge big time if you're going to do them by hand. So you can still take a picture of those and include those, and it's fine. It's acceptable 100%. So those are the questions that I thought we should talk about. The first one, namely the projects. Okay. Let me go back. I still have more items in mind, okay, to talk about, especially this week's content, because I think we need to come back to it a little bit. So the second one is the Geogebra homework. So let me stop this sharing the screen in here, and again, come back to it as I am one of you guys. So I'm gonna be sharing my screen in here. So I submitted, I know exactly how I'm going to be marked in here and so on and so forth. So I got all of the questions in here, so that helps me in terms, this is the 5 points that I was talking about in here that you're going to lose unnecessarily, okay, for those graphs. Here is another graph, okay? And so all of these things are important, so please take care of them. So now I'm done with this. I submitted it. Okay. Okay, it's asking me to actually submit, so I don't want to do that right now because I actually, or should I do it? Okay, let's do that. Okay. Okay, submit. Okay. Hey, it says I'm done. Okay, apparently I can only upload one file. You see how you discover problems? Okay. There are two options at this point. Okay. If you need to include more than one file, you have two options. There is an option called the zip. Let me go back and show you exactly how you can do that. Okay. Let me share the screen where we were earlier. Remember, we had the file sitting on a folder by itself. So let's say, for example, I have an image or a text file or something else. I'm going to add a new file in here, which is a text file. So I have stuff in it, okay? And I'm going to add a new file in here. And let's say, for example, a PowerPoint file, okay? And just to make it a little bit more interesting, I'm going to add a third file in here, which is probably some script file from, I don't know if you guys work with Mathematica. So I have a bunch of things, including pictures and things like that, but it's asking me to upload only one file. So what I do first in here, I'm going to take all of them, select them all. On my computer, you right-click on it because I'm doing Windows. I'm going to send to compressed, zipped folder. So it's going to be a zip thing. Okay. And here is the document that was created for me. It takes all of these files and make them into one file. That is 100% acceptable. So that's another technique that you guys can do. So instead of uploading this file and that one, and this one, and this one, and probably 20 other pictures together, you can combine everything in one zip file and upload that file instead. So when I go back into my instructions, I could do that. You guys understand this idea too? That's one solution to the problem, okay? If in case you have more than one file. Another solution, which is fine too, is to email me. Hey, I uploaded the PDF file, but I just remembered that I couldn't add the two pictures. So here are the two pictures. Please make sure that they are added to my my project, okay? And you have to specify the project that you want me to post it to them, because when time comes to grading, sometimes these things that you have in mind are probably lost in the discussion with time and things like that. So be very specific and clear in your email. Okay, so you have two options. Both of them will solve the problem. The last one is always a solution no matter what. The first one is if in case you really have more than one file and you're restricted to the number of files, then in this case, you just basically put them all in a zip file and send them all as one file. And then when I open them, basically from my end, it's going to automatically unzip those files and put them all in one structure together for me so that I can be looking at them at once. So this hopefully answers the questions for the project, how to upload stuff and do things. So let's go into the other screen now. If I continue with this thing in here. So basically I have done this project in here and I'm done with it. So let me go back into the model since I'm still in the student view mode. And it's telling me I have done that. And one of the things, after I do the gravity activities in here, okay, this gravity is a little bit different because of the issue that I had with those tabs, because some of you probably were missing the tabs. So what I did for this one, I divided it into different sections, which is how the chapter is divided actually, and I tried to put them together in video recording. So hopefully you guys are going to be reading still the chapter, following the instructions in the video, or at least some brief stuff in the videos, and then basically finishing with all of this thing. So we're done with this. Let's say, for example, we did this, and some of you actually have done that. It takes me to this quiz in here, and it's telling me the first thing it tells me is that I need to go and visit this link. So all I have to do now is double click on the link or click on it, and it takes me to this link. Do you guys see this window that just popped up that says First and Second Law of Kepler?
Yes.
Okay, very good. So that's the link that you're supposed to be in here. What I need you to pay attention to are this word in here. It says the semi-major axis, which is this distance from here to the center of the ellipse. The major axis is from this point, which is called the perihelion, which is when the object, the planet, is the closest from the sun, all the way to the aphelion, which is as further as can be from the sun. Okay, that's one thing. The other point that I want you to look at is also the semi-major axis, B. So the symbol for this one is A, actually, and the symbol for this one is B. B is this distance from when it's in the spring solstice, equinox, which is this distance to the center of symmetry. This distance is B, and that is half the minor axis. This is the minor axis. So this is the semi-minor axis here. Twice of that, 2B, is actually the minor axis. So those are two numbers I need to be paying attention to. The third number I need to be paying attention to is the position of the sun. The sun, per Kepler's second law, must sit in one of the focal points. The distance from where the sun is to the center of the ellipse is the focal distance. It's actually the symbol C in this, this equation in here. This distance is C, from here to here. Obviously, there are two focal points for this ellipse. There is one at position 4, and there is another one at position -4. Mr. Kepler says that the sun sits in one of them. I chose it to be sitting on the right. Okay, so that's basically where this the second law of Kepler says. So basically, he looked at the data that Tycho Brahe and other people collected, and he was analyzing the data, and this is what he found. That the first, is it the first law? I'm sorry, this is the first law. The first law is that this is all of the planets, they go around the sun in paths that are ellipses, and that the sun sits in one of the focal points. So this is the first law of Mr. Kepler, okay? So this is the description of that. So this is 4 in this coordinate system for the sun, for C, 5 for the semi-major axis, this distance. B, per this formula, which is the Pythagorean theorem actually, is just 3 square root of 25 minus 16, because I have 5 squared, that's 25, and 4 squared, that's 16. Square root of the difference between them is 9, is 3, exactly 3. And then the eccentricity is how flat this ellipse is, okay? Because if I change this number, for example, to 4 point, I think at some point it's going to ask you to 4.25, I'm going to make B bigger. I'm going to make it a little bit closer. I'm sorry, did I make it bigger or make it worse? Okay, let's go back into here. I brought the sun actually closer to the winter solstice. So I make it actually flatter. Okay, so B went smaller actually in this case. Okay, so let's make this the position of the sun closer to the center. So if I make the position of the sun closer to the center, let's make it 0.25, for example. I don't want to put it exactly at 0, but I'm going to put it very close from the center. Now it looks like a sphere, actually. B is 4.99. That's this distance from here to here. It's not exactly 5. It looks like it's 5 on the screen, but it's actually 4.99. It's very, very close from 5. And in here, it's exactly 5. Okay, so this screen now, and the eccentricity went down big time. I don't know if you can see this number or not. Yeah, the eccentricity went very, very small compared to what we started with. Okay, so this is where we started with. Okay, so the eccentricity is 0.8. It's almost 1. If I actually put it 5, it's going to be exactly 1. Okay, and that is not an ellipse anymore. As a matter of fact, at some point you're going to put more than 5, and you will see that everything else breaks down on you. Okay, okay, so 5 1/4 that puts the sun, puts this planet completely out of reach. I mean, it's going to pass only once around the sun probably. Okay, that's part of your reading. You really need to do this reading in here from the chapter and have an understanding of what this physical law is. Let's go back into 5.5, for example, and just to show you there is something weird happened about the semi-major axis. It doesn't exist anymore because this square root becomes square root of a negative number, which doesn't exist in the real numbers. Okay, and the eccentricity becomes bigger than 1. So those are some of the things that I'm going to ask you to go and make sure that you complete the question by question by question by question by question in here. The second law of Kepler has to do with this area. And here it's kind of off a little bit. This entire area from D on the arc to E to back to the position of the sun. This area and this area from the sun all the way to the position G and F, and actually this arc distance, this angles, these areas are the same. That's what the second law says. The third law in here, which is not depicted in this graph, is actually asked in a question later on in the same assignment, has to do with the time it takes for the sun to go, for the planet to go once around the sun. Take a position, it doesn't matter which position is. Today we are in July something. No, I'm sorry, we're still in June something. So we just passed the summer solstice, which is here, okay? The summer solstice is here, June 20th. We're just June, what is it, 30th? So we're just barely on this side now, okay? So if we wait another year, June 30th, 2021, the Earth would have gone through the entire year and come back in here. That is 1 year. That is P, the period. The semi-major axis is this distance, okay? So if I take P squared, it's, according to the third law of Kepler, is proportional, not equal, proportional to A cubed, to the cube of this distance, okay? So that's the third law. It took him a long time actually to come up with the third law, but that's basically what the third law is of Kepler. So again, this entire exercise is on the three laws of the Kepler. This specific one is on the first and the second law. And all of the questions that is asked, change this, change that, put a number in here. So these are the fields you're going to be playing with. It's mainly actually this one for the position of the sun. And this is the other one that you have. And meanwhile, you're paying attention to what's going on with these numbers. Okay? So this is the second point that I wanted to talk to you about in terms of what we thought we should be talking about. Oops, not this one. Here. Okay, so that's the second one. The quizzes are the quizzes, so I hope that you guys read the chapters, try to understand them. If you have any questions, ask them, try to ask them in forum format, okay? So that we can have discussions in there. If something that is, I'll be more than happy to discuss them. Now, if it's a personal issue, trying to do something and you can run into difficulties with it, you can always ask me about them if you feel that it's not revealing any kind of private information. I mean, if you feel that it's probably, okay, so I don't know why this thing is doing that. Anyway, if you feel that they are going to reveal anything, please ask me, so that other people will know about them. But if it's something like, for example, I may have difficulty with this or that, sometimes another person who have gone through that and have resolved it or asked me the question, probably they can help you faster than I can do, okay? So it's a good idea to go from these general questions to a forum and ask a question in there, and hopefully that's going to enrich only the topic and make it more rich, okay? Again, it's only with your questions that make this thing more interesting. Okay, so that's the second part. Again, like I said in the beginning, we have two quizzes. One of them is already was started on actually Monday or Sunday actually. So that is for the last week. And then we have another quiz that is actually started today for the chapter that is chapter 3 actually, which we just discussed right now. Part of it is its homework. And then the other thing also that is going to be is chapter 4 is going to have another quiz also, which is also in this lesson 2. And finally, chapter 5, depending on how we go about it, okay? So that's in terms of the quizzes. Any questions for the quizzes? No? There was a problem that one of you has raised it, and I think I fixed it, okay? But one of the questions that was wrong, okay? So I think only one person at that time has taken the exam at that point. So I fixed that, and that should not be an issue anymore. Now, if you discover another issue, for example, you're confident 100% that your answer is correct, and the system has granted you the wrong answer, please let me know, okay, at once, so that if it's a problem, I will fix it, and then whoever basically answered it, hopefully they will be credited with the correct answer, and if they still did something wrong, I probably will have to work out something for them. Now, if the people who did not answer the question, then they will be starting afresh. Okay, so they won't have a problem. Because there is another thing that you need to know, guys, about this test. Okay, they are random tests. Basically, they're coming from a data bank. So some of you will encounter the question, others probably will never see it in their exam, even though probably they might do it 3 times because, again, it's coming up from a random data bank, basically, so that it's going to pick up those questions at random. So probably one person will see a question, and maybe from the entire class of 20 some odd students, maybe 2 more will see that same question. So the others probably have no idea that something like this has happened. Okay, so that's just an FYI for you guys. The same thing for the midterm. Midterm is actually going to pick up on this quizzes. So please take care, make sure that you do this quizzes, because actually they're reviews for your entire midterm. So the midterm is heavily weighted. It's 20% of your grade. So make sure you do these quizzes, because they're actually preparing you for that one too. So it's important. I know the quizzes, they're weighted a lot less. Besides, we dropped at least the 2 lowest grades in them. So that's in a sense there is less pressure on them. But the biggest incentive, I mean, of course, you want to pass the grade, so you want to have to do all of them correct. That's a big incentive as it is, but actually they are preparation also for the midterm too. So you need to make sure that you do those things too. So that's a word of caution for in terms of the quizzes. So please take care of them and make sure that you have them all in working order. Okay, what I want to, the last point in here that, no, actually there is another point that I want to share with you guys too, if you guys will allow me. So let me finish this point in here that I was going to talk about, and namely the lunar, there is a link in here, and I probably will include that to you guys. Okay, I'm gonna post this one on Canvas, okay? So the link so that you guys can go and look at it. It's from the timeanddate.com website, okay? This is a great website. There's a lot of resources, and including basically the position of the sun, the moon, basically astronomical basically events, and sometimes people will tap into it for astrology. And it has actually something called an API where people can basically pull their data, and they have subscriptions and things like that. But all of it is scientific, so it's a great actually resource. So I want to go to this link in here, and I actually went to it already using a browser. So let me stop this sharing in here, and let me go and find that browser. Okay, I think that's the one. So this is how it looks like when you come to it. I actually opened it with Microsoft Edge. On how it looks like from your location, wherever you are. And here it knows, or at least it found that I am in San Bernardino. So it's telling me how this lunar eclipse will look like from my location, where I am at. And it's telling me, can I see it in San Bernardino? Absolutely, yes. That's what it says. I'm going to see when it begins, when it's going to be maximum, and when it's going to end. All of these events are going to be recorded for me. I know specifically when I can go at night and look at it. At 8:07 p.m. tonight, I mean, not tonight, I'm sorry, on July 4th, Saturday night, that is, I can go outside in the sky. Hopefully, the sky will cooperate with us, and usually it's a good thing in here in Southern California. We'll have nice skies. We'll go and look at the moon and start seeing it. I would recommend you go a few minutes early, because I want you to experience 2 things. First of all, the sun will be setting during that time, so there will be a lot of light in there interfering with your observations. But then when the moon starts to see a shadow on it, okay, and the shadow is coming actually from the Earth itself, okay? So I'm gonna play this recording in here, and you will see the beginning, and it's going to pause for you to tell you, hey, it started in here at 8:07 p.m. my local time in here, and it's gonna reach its maximum. It's not gonna cover the entire moon. That's why it's called the penumbral eclipse, because only part of it will be covered. That's the maximum. Let me go back in here. The maximum will be here around 9:30 my local time. 9:29:51, almost 9:30, okay? When it's going to be its maximum, and then it's going to start to look brighter again, okay? Because it's going to leave the shadow of the Earth, and it's going to appear brighter again, okay? So that is an event that you're encouraged. Again, it's the 4th of July, and there is no better day probably than this day to do this. And I think you're blessed, guys, with this. And it's going to end around, at least for my location, around 11 p.m. or just 8 minutes before 11 p.m. Okay, so that's basically how this part of this observations. Again, it's part of your work again. So again, in here, this is giving me a resource into where can it be seen in the world. So we're blessed in the sense that we are in Southern California, and it's giving us this view for it. And actually, if you look at it, we are just on the line itself. I mean, this is actually misleading. So if I go back into here, the eclipse map, and if I look at it, actually, this is the full eclipse region. It's actually South America, most of the United States, and a little bit of Western Africa. And if I put in here San Bernardino, where I am, or Riverside, where some of you are. So I'm going to put Riverside, California. And it's telling me Riverside, California is just on the edge in here. And it's telling me when Riverside, California will see it. Again, 8:07:23 p.m., 9:29:51 p.m. And this is basically when it's going to be all of the times basically when I can see it. The magnitude in here, the smaller the number, the brighter the object in the sky. So this is going to be a negative number, so it's going to be super bright. Hopefully there will be no clouds whatsoever, and then we can see this event. I'm going to open my telescope that night. I'm going to actually pull my telescope and then go outside and see if I can record that and post it on YouTube and give you the link for it too. Okay, so that's an event I really don't want you to miss. Again, it's part of your assignment to do the lunar observations, and you're blessed in the sense that you have this one going. So I want you to point you to this resource, and hopefully you guys will go outside and do this and complete that task and include that in your report. Any questions about these items that I was going to talk about today? No?
I have a question about the retrograde motion project.
Mm-hmm.
Could you briefly go over question number 8?
Okay, let me see what question number 8 is. Okay, the question number 8, what is the position of an exterior planet like Mars or Jupiter midway through its retrograde motion? Okay, so let me go back into the instructions and let me find them first. Am I still in the student view? Yeah, let's go back. Leave page. And I'm preparing just to go back to the instructions. Okay, so please open the instructions also with me so that we can see the retrograde motion. Okay, so let me make sure I share with you the screen from that instructions. So where is Zoom? Share. Okay, midway. I forgot the question again, the whole question. Okay, make sure that we answer the question correctly, okay? So the question says, what is the position of an exterior planet? Mars and Jupiter are exterior planets. They are not interior planets with respect to the Earth, okay, when they are moving. Midway through their retrograde motion. So again, here is Mars, or an object outside, okay? And as the Earth is overtaking it, the object is actually moving a little bit slower. So this is where it's going to start, and this is where it's going to end. And this is the position where it's going to be. So what is the answer to the question? Fabiola, what is the answer?
Opposition.
That's good. That's the answer. Okay. And similarly, with the case of the interior planet. Okay.
Okay, sounds good. And
okay.
just one more question.
Mm-hmm.
I was able to find all the dates for the next occurrence, but I just wanted to ask, will you be deducting points if they're not accurate to the dates you have?
As long as you basically did the calculations, I know that there are some months that are probably 29 days, and some of them are, at least February is, and some of them are 30 days and 31 days, and you may be off within a few days, okay? That's fine, okay? As long as you did the calculations there. But I don't want it to be off by several months, okay? I don't want it to be telling me that it's gonna be in October of 2020, whereas I do the calculation, it's gonna be actually January 2021, so it'll be off by this much. Okay, if it's within few days, it should be fine. Okay, so if you did the calculations and the calculations are correct for the S, and you had a problem finding the date, it should not be a problem. Does this answer your question now?
Yes, thank you.
Okay, okay. So at least we answered some of these things, and let me actually share with you the other screen, the one that we were in right now, because I want to talk about the chapters that we have going right now, because I want to make sure that you have a full understanding of what's going on with these chapters, unless you guys have a different question. So these chapters, we have gravity, which is the chapter that you are quizzed on it in two different ways. First of all, you have the quiz, which is in here in the bottom. And then you also have the homework on it. So it's heavily tested. I put a lot of videos for this, basically of how Mr. Kepler came up with his 3 laws based on the observation of Tycho Brahe, and then also how Mr. Newton was asked to explain these things based on his own 3 laws of mechanics. The first law that says basically objects that are under no net forces will stay in their places if they are not moving, and if they were moving, they will continue moving in a straight line. And so what's going on? Why is the Earth then going in circles? Why it's not going in a straight line? It's because there is a force. Then we answer it with the second law of Newton, that if an object is under net forces, then it's going to accelerate, and that acceleration is proportional to the force and inversely proportional to its inertia. And it turns out in this case that the change in velocity is the change of the direction of velocity is what this force is doing for the most part, because the eccentricity of the Earth is very, very low. Actually, as a matter of fact, it's very close from 0.016, which brings it to almost circular path, but it's not quite circular. Okay, so that's some of the things that can be explained with the second law. The third law, which says that if two objects can interact, they will do so in such a way if one object exerts a force on the second exerts a force that is equal in magnitude and opposite in direction. And as a matter of fact, the full problem, even between the Earth and the Sun, for example, or the Earth and the Moon, is not a single body problem. It's a multi-body problem, because you have to look at it also from the vantage point of the Sun. The Sun is being attracted too by the Earth towards the Earth. So as the Sun is pulling on the Earth is actually pulling on the Sun too. For that, the position of the Sun is not actually fixed. The Sun wobbles around its direction. Granted that the Earth is not the major player actually in the solar system. There are other planets. For example, Mercury is closer, so its effect is higher because of the distance, but its mass is a lot less than the Earth. And it's a lot less than Venus. Venus is actually closer to the Sun, probably will exert more effect than the Earth, because its mass is not that big of a difference compared to the Earth, but its position is a lot closer. And the force is inversely proportional to the distance squared. So the closer the object, the more effects it's going to have. As a matter of fact, Jupiter, which is supermassive, albeit is far away, but it will exert far more effect on the Sun than any of these 3 objects. So the point being in here is that this is a multi-body problem, so the third law is actually needed to understand these things of what's going on. This was the basis for the discovery actually of Neptune, because once we were studying, for example, and when Uranus was discovered, people saw, hey, there is a problem with the motion of Uranus, okay? In order to fix this problem, we have to include other things. We have to see, oh, maybe we include Saturn, which is the next closest planet. We can find the correction for that difference, the discrepancy in the motion of Uranus. Well, that corrected some, but not too much. Then maybe we can include Jupiter also. Jupiter corrected a little bit less than what actually Saturn did, but it did not correct much. So the only thing that was there is maybe there is another planet out there that can bring that 0.03% discrepancy in the motion of Uranus down to 0%. And sure enough, if we are going to look, here is where we're going to look. These are two mathematicians, one French and one English, basically, Adams from one side and Leverrier from the other side. They did their calculations independently of one another without knowing of what the other person is doing, and they found the mass and the location of planet Neptune mathematically. This is nothing else but math. This is because Mr. Newton has come up with a theory, and based on his theory, we were able to predict so many things and find things like, for example, Neptune, which is a big planet. It's not a small object. It's actually in mass, it's bigger than Uranus. But it's further away, we couldn't see it. Until now, we cannot see it with the naked eye. We have to really have some equipment for us to look at it and to find it. So that's how basically Neptune was discovered. It's based on this thing. So it's Newton's laws that was and enabled us to do so many things. So I want you really to have that appreciation for this thing. Because and again in here in the next chapter, the Earth and the Moon and the sky, and it gives you basically how we locate objects in the sky using the dome above us, basically, and how we use the angles, the right ascension and the declination, which is part of your retrograde motion project too, so that you have an understanding of how to locate precisely objects in the sky using those angles and things like that. So again, this is all of this is just preparation for the next things that are preparing us for the next few chapters. This is basically the science behind astronomy. Because with what confidence can I say such and such thing is there? How can I explain it physically? So that's really how the thing is. So if you don't have a foundation in science, everything else just becomes a theory. Everybody can just come up with his own version of it. I dreamed of it, or somebody told me that, and I can explain Kepler's laws. That is not good enough. You have to have something that is based in science, that can be tested in the laboratory, that can be observed, and then can predict something that you cannot do without this theory. And that's what Newton's basically law did. Among other things it did, and I talked about that in the recording, it predicted the position of the Halley's Comet. When it was first seen, and then reported that it was seen, then based on the calculations, this is the next time when you're going to see it. 76 from today, 76 years from today, and this many days from today, at this many hour, you're going to go outside and you're going to see Halley's Comet. This is the power of science. Sure enough, it came back in that exact same time based on this thing. Now, this theory has limitations, and I think I mentioned that a little bit about everything else, that, for example, the path of Mercury, it wobbles, okay? It's not exactly on the same ecliptics. Actually, it wobbles. And people try to explain that including, for example, the effects of Venus on Mercury, the effects of Earth on Mercury, the effects of Jupiter, which is the biggest player after the Sun on Mercury, and so on and so forth. But Mercury still defied all of these things, and couldn't really explain it without having to resort to a new theory of mechanics, and that is relativity. And that is where Mr. Einstein came in and said that forget about all of these things that you've learned from Newton. I have a better explanation for everything else, of how Mars, for example, goes around the sun, and how Earth goes around the sun, and how the moon goes around the sun, for example, and how the apple falls from your hand. And also, I'm going to explain to you how Mercury goes around the sun too. And he was able to do all of that. But again, if he was only able to explain what we see, that is not good enough. He needed to predict other things that we couldn't see before, or we couldn't do before. And sure enough, among other things, for example, is the gravitational lensing, basically, that you can use the gravity to bend light. And in the eclipse of 1919, a few years after his theory, actually that was observed too. So again, a theory is powerful when it can predict things in the future. So that's basically what I wanted to share with you, at least in terms of these few chapters. I want you to make sure that you read the chapters, you go through them. And if you have any questions, please do not hesitate to ask them, okay? I wanted this recording to go for about an hour, and I'm gonna post it, but usually when it goes a little longer, it doesn't really become too productive, okay? So any questions so far? If no, I'm gonna post this one tonight, and I'm gonna continue working on your content, and hopefully you guys will enrich it with your questions. Does this sound like it's a good plan? Okay, very good. Okay, I guess I will see you guys. I will post stuff like this one, and maybe if there is another point, and if you guys want to ask questions, I will be more than happy to continue with these discussions later on. Thank you. And be safe, okay?